I hope you're going to be on board with what I'm going to tell you right now as well. This is about minimal status reporting using NMOS. And I'm going to dive right into the topic about the history and the motivation behind all of this. I'm from a company called Simplexity, and we are working on behalf of Swiss Radio and Television, the Swiss public broadcaster. And they were one of the early ones doing full IP installation. And I was happy, or I'm still happy that I was involved in there. They're on air since 2020, and it's working, it's cool, you know, all great. But one of the issues we still have there is actually that a lot of operators are working mostly blindly if it comes to networking and the IP side. Thanks God it works, but you know, there is a second phase to that. So they wanted to do a second phase where the whole monitoring on packet, on stream, on network level comes in. So we started to discuss with with some of the key vendors what's possible on eye level, actually. So we consolidated that first phase, and then we started the next one, and we said, what's possible? What creates a lot of effort for you, or what's doable, and all this kind of stuff. And it became pretty obvious that we need to reduce to the max. Basically, we can wish a lot of stuff, and there's obviously a lot of very sophisticated monitoring systems out there. But you know, we wanted to have a very practical solution, which is doable for the manufacturers as well. So what we did is actually we consolidated on 4 what we called alarms or statuses, and wrote a white paper about that. That was published, and we got a lot of positive reactions from other broadcasters. So then we went to AMWA and said, you know, why don't we standardize something using NMOS, so you don't have to write drivers for every single device doing this. So AMWA was very welcoming that initiative, and now I'm very happy to introduce you to a specification called BCP08, which actually standardizes a minimal status reporting. A minimal status reporting. Doesn't do everything you can dream of, but it's doable. So the goals of this whole thing was basically monitoring key elements and allow flexible setups. That means also, you know, go the step further, which we all want from IP, being flexible, maybe moving devices around without then manually do a lot of setup on that. So, what we came up with is what we call a traffic light approach. We basically distinguish between 3 states, and obviously also a non-active one. Red, yellow, and green. And basically we always say, okay, is something healthy? Is it partially healthy, or is it unhealthy? Specification is obvious. Healthy is whatever we are monitoring, a domain, a service, let's call it service for now, very generic thing for now, is healthy, it's working, and it's okay. There's no irregularities. Partially healthy is yellow, right? So the service is still okay. There's absolutely nothing wrong with what you get, but there is something you should probably look into. And the red, obviously, their service is not okay. So what we mean is actually, we are targeting the end users. We are not targeting the experts who can already today dig into log files and stuff like that. We are targeting users on MCR level and whatever, and let them know and grow confidence about the IP side. So on a yellow state, they should probably do something in the next break. On red, they should probably call someone right now. So on that traffic light approach, it did that before, so I'm just going to stay calm. And it's going to come up again.
There's a button under there. There's like a mute button.
A mute button? Can you do that? Thank you. Which one?
That one.
Oh, wrong button. Okay, so what's the point about this traffic light approach? First, we move some intelligence into the edge devices. We don't centralize everything because we believe some of the simple stuff is always the same and really should be decided by the edge devices already. So by doing that, we reduce the overall system complexity, setup work and all this kind of stuff, and we allow, in some cases at least, a straight mapping to user interfaces by doing that, without a lot of intelligence in between. Second point, which is quite fundamental to this approach, we work with active notifications, not polling. So we need a protocol, we needed a solution which is able to notify subscribers, let's say, and say, hey, here's a state change. So that obviously reduces traffic on the network, but also reduces monitoring load, you know, whatever you have. So we want to go from small to big. We want to have a little $200 device in mind as well as the $20,000 devices. So we also said all the reporting should have a delay of 3 seconds as a default. We want it to be very practical. And that means before a device returns to a healthier state, so red to yellow or yellow to green, it has to have that state for at least whatever that delay is, which defaults to 3 seconds. So you shouldn't get flapping, all that stuff. So that's another kind of corner rule which we introduced there. The other one is we map the status to senders and receivers, because that's where the signal starts or arrives. That's what the operators kind of focus at the end. So we don't kind of make a distinction between device related and whatever. We map it all to the senders and to the receivers and say, hey, is it green, is it yellow, is it red? So some other corner elements to this. We do have -7 in mind. So, you know, obviously, if you lose one network, the other one's still up and running, you only go to yellow. If you lose the one and only network you have, you go to red. That kind of stuff, right? We have a message field for optional information. So we want to keep this open as well for the manufacturers. They can always fill in that message field with a cause why it's in that state. But we don't tell them what they have to write in there. It's down to the manufacturer. But again, we expect some UIs to actually reflect that message to the users. There is a possibility to execute commands, some of them, like resetting counters and stuff like that. And the whole thing is actually open to fine-tuning those conditions. So the manufacturers can still decide, in my device, this is actually still yellow because we are able to still continue the service under whatever conditions. So that's actually quite open for that. It's also possible to extend with additional statuses. We only define the minimal statuses. Manufacturers can put in more if they want. And generally, we are not just focusing on 2110. We are actually also having older, even asynchronous technologies in mind. Now, let me introduce you to the, let's say, reporting domains. The 4 errors I was already mentioning, the minimum which we expect every manufacturer to do. The first domain is about connectivity. So we basically ask, is all the data arriving? And that has 2, let's say, subdomains. One is actually packet level. Do you get all the packets in time? And the second one is, do you have a physical link? Obviously, the first one indicates already when you lose a link. But we introduced that physical link thing because we expect this to be very practical usable. That, for instance, in a dynamic setup, you know, hey, someone didn't connect that cable yet, right? Then the second one is synchronization. Do you have what you need? And the third one is actually, can you decode what you get in the packets? And finally, there's a fourth state, which is an overall state, which actually is the minimum for someone to look at. And it will always have the worst condition of the others, right? So if all of them are green, the overall status is green too. If one of them is yellow, it's going to go yellow. So again, with a message field which says which state it would be. So that's basically it. Now I'm going to just by example walk you through those 4 errors and the traffic light conditions. And it's pretty obvious. Basically, you know, on the connectivity on a packet level, green means I got all the packets in time. Yellow means I got some packets missing, but I can actually recover it, let's say from the second network or whatever. And yellow means I got, we got packet loss. Now the message says maybe the reason, but there's also counters. You know, there is the the device should report how many it was, and you can reset those counters. So that's just one of the 4. On the link level, it actually gets even easier. There's no counters. It just says, I got all the links up, or some links are down. You notice we don't say 1 or 2 or 3 links. It's just some links, which I expect to be up, are down, yellow. So we try to be very generic. On the sync state, we actually say, do you have all the sync, the external sync you expect? And we would go, by the way, inactive if you are on internal sync. So here, you could even expect black burst or whatever. It's just, do you get the syncs you expect, yes or no? Or is some you expect not there? That would also apply on a -7 network to both networks. You expect on both networks to be PTP, and if one of them is missing, you go yellow. Interesting here is we have a counter of the number of times you changed from one sync source to another, including grandmasters. So you would be able to detect there was grandmaster changes, but you're still fine, but there was grandmaster changes, which obviously shouldn't happen in normal conditions. So we had that. And then finally, we go to the stream validation. Basically, this says, can you decode the streams? Are you able to do that? Or are you not? Basically, I would expect most people just go between red and green. But actually, there are some yellow conditions where you see, hey, I am able to decode that stream, but actually what I see, for instance, in the SDP file, doesn't match what I'm actually getting. That kind of, let's say, irregularities. So that's on the stream validation side. Now, the important thing is, the interesting one is actually the overall status. The overall status, as I said, always reports the worst conditions. And that's the minimal thing you can use. And actually, those colors could be reflected right back to the UI, say, you're green. By the way, it also says, we have some details which I'm not going to go into during the presentation, but when you make a connection, you actually go green first, and only after 3 seconds you start going worse if there is something. So we want to avoid all wrong indications during the moment when you start establishing streams and stuff. So we try to be very practical here. So basically, that's where you can go. That can all be right away reflected to the monitoring system. And if you have a monitoring system, if you talk to these guys, they also say, well, great, we don't have to set up all that logic again and again and again. So even if you have all that power in the monitoring system, it simplifies your setup work. And finally, if a vendor has more status to report, the overall status would still be derived from that, and they would basically indicate all okay things. So that's quite flexible, that overall status. So what's the technical prerequisites? Manufacturers doing BCP08 need to implement IS-12. I know it's not very common yet, but IS-12 in combination with MS-05, which is the model specification, they started to split those documents slightly, so they belong together. These 2 documents describe what I would say a model number plus, right? It's basically using REST API, WebSockets, and all this kind of stuff. It's a very generic approach. You can do many other things once you have implemented these 2 documents. And one application is BCP08. How do you report errors or statuses? So this is actually what the vendors need to do. And yes, that's probably the biggest work they need to do. Not so much reflecting the statuses, because we expect them to have them anyway internally somewhere. So let me just give you a quick check on practical applications or use cases which we could think of. You know, issues like dirty or aging SFPs, whatever, or you have sync problems, degraded PTP layers, whatever. The overall status is always the worst of all of these on the right-hand side. And you notice that sometimes it's yellow and red. Well, the point is, it depends whether you have a redundant network. Then you're going to go yellow, or otherwise you go red. So that's why I couldn't decide on whether you're going to see yellow or red here. But basically, if you go through all these, let's say, possible problem cases, you will find that you will always get notified about what you see. And then you call the experts and say, hey, there's something wrong with my network. So, what's the benefit of BCP08? By the way, the 01 and 2 distinguishes between senders and receivers, so it's not relevant for today. Basically, we want to have a driverless monitoring of most important AV over IP statuses. It's in line with the whole NMOS plug and play, so it registers itself on ISO4 registration server. It focuses on the users, so it allows to react. It doesn't give you all the problems or solutions already, but you know who to call, basically. And it gives the users a confidence. It sheds some lights into the networking, which maybe they don't today. It's kind of a black box, and they say, oh, don't know what's going on there. So it covers a wide range of systems, from small without any monitoring system to very big with monitoring systems. Then they get simplified. Basically, the minimal effort is basically, once you have done the IS-12 as a manufacturer, it should be pretty easy to do what we propose here. And the whole logic and the setup of your installation is simplified significantly. So the whole thing is open to expand. You can report more statuses if you want as you can use that to do more than that. But the minimum status report, BCP08, is what you should do as a vendor. So basically, as a summary here, BCP08 reduces to the max. It's basically only reports practical and essential stuff. You should not see full screens of stuff you quickly learn to ignore and then never watch. The obvious logic is moved to the edge devices, not to the central monitoring system. It allows simplification for monitoring systems for all kinds of sizes. It's based on NMOS 12, and so it makes sense to you to really implement that. And the current state of discussion, just that you know, we have basically publicly made the receiver specs. We are still working on the senders. They won't be much different, but you can actually go and check it out. And we are welcome basically feedback on this whole thing. There are documents on this, the general AMWA homepage, but also the current link here. You're welcome to scan it or whatever. You'll find it. And the white paper from SRF. So, kind of caught up on time. Thank you. Wow.
So, yeah. We have to bring on some more food for the afternoon, so we're going to need a few extra minutes.
I'd love everyone to speak IS-12, but Rossa preaching Katina, Lavo want everyone home, and what I get in the end December plus.
What's the question?
Who speaks IS-12?
I mean, basically, right now, that's exactly the point. Obviously, we need to standardize on something, and the others are not open specifications. And the point is, you know, ultimately, we can't rule the world, but it's a trial to at least not do it yet in another proprietary approach. But ultimately, it will be the end customers asking the manufacturers to do it in a certain way. And here is the one and only open publicly available specifications for it. I can't solve the problems of the industry, but it's a trial.
Yes, thank you. This is Stefan from Net Inside. When we're doing this fault seeking, I got kind of a problem that I've been bouncing around with support people, that I have an RTP clock that is 900,000 microseconds wrong in time, and the device is clocked. You see in the PTP track count, you see the black burst output, and you see it on all these tools. And it's hard to explain all these support people, and these kind of tools are great, but it's still missing these kind of standardized. I do the VAN side of connecting all these Arista, all these spine leaves around the world in one unified 2110 network. And there's one NMOS controller here, there's one NMOS controller there, and so on, in a worldwide network that I'm doing. So for me, it's that support tools that's coming more in these what it does as part of you talking about is very important, but we have to evolve it much more. And for me, it's a question. The support call they pay for us, and then you have to have an ordinator or a love or whatever it is. All these support organizations have to talk to each other. It ain't just have a way to get an alarm. For me, this is because most of you go in your small LAN network, but I'm doing the WAN sign and connecting all these in 110 networks.
There's always room for improvement,
of course.
more. But I just quote Hartmut, just consolidate a good first step. And we try to make a first step, improving what we, from an operational point of view, consider the most important thing. So it's achievable, it's practical, it's realistic.
Yes.
And then we can go further than that. Absolutely.
Yeah,
There's lots of stuff we need to go further.
There's REST API and things like that. Yeah. Thank you.
You're welcome. So, whenever you have a chance, go to the manufacturers, ask for this. I know a lot of broadcasters already do, but it actually, for them, there's no business case unless you ask for it as an end user. So, just go and ask.
Yes.
So, if you are only having IS-12...
Maybe you want to hold the mic just for the
Can
recording.
you hear me?
Right?
Okay. So, if you're having your IS-12 in the receiver side only, but not in the sender, will the traffic light system work? Or it has to be implemented in both sides, meaning that it has to be standardized across all the devices in the network in order to have a result?
So the answer is no, it doesn't have to be everywhere.
Okay.
Basically, you publish as a device, you publish in the ISO4 your ability to talk IS-12 and whatever. And then if a UI wants to use that, they basically, via IS-12, ask for the statuses there are. So if they're only on the receiver side, it would just show and no, there's only the receivers and maybe only a few of them, I don't know. But it's basically, you can ask through IS-12 mechanisms what's there, and then you can map those. So that's why it's called BCP now, 08. It's because there's no change to protocols. BCP 08 is the cooking recipe, how you have to basically use that data and what it should and when it should indicate what. And again, I'm not telling you we've solved all the monitoring problems of the world. I'm not telling you, but maybe a big portion of it. There's one more question on that side.
Actually, we're out of time. I'm going to have to ask everybody to leave the boat. We just don't have any more time, or we're going to run late for the rest of the day.
Just a quick question, maybe.
Okay, go
Are there
ahead.
still some